Hello everyone, Dmitry is here. I'm welcoming you from sunny Melbourne in Victoria. It's a Friday afternoon, plus 25, really nice weather. And next 10 or 15 minutes, we're going to spend talking about Azure Machine Learning and my final project for CSCI E-90 course in Harvard Extension School. So for the project, I decided to explore Azure Machine Learning Service in Azure Cloud Services. It's a service that enables users to build machine learning models, to deploy them, to test them, and to do all kind of data science magic. Before we dive into Azure Machine Learning Service itself, we need to do some housekeeping. So to create any services in Azure, first and foremost, you have to have a subscription. Subscriptions serve as a billing unit. So that's where you submit your bank details and name of subscription, pretty much that's it. That's how you can do it. Just click add and subscription button, give a name and all the details required. A user can have multiple subscriptions, which make it a very nice feature to track the costs separately. As you can see, I have one active subscription, which is final project, the one that refers to the presentation I'm doing right now. After we've done the subscription, another step is to create a resource group. Resource group in Azure serve the purpose of combining all assets, all services that you're going to be using into one place. Make it easier to create, make it easier to monitor, to maintain, and eventually delete all the services. You can actually track the cost by resource groups, which make it another very nice feature for reporting and for analytics. So as soon as you've done, if you have a subscription, you have a resource group. Next step will be to go and actually start doing fun work. And by fun work, I mean creating a Azure Machine Learning service for us. So you need to find the Azure Machine Learning service here or maybe in the search bar. So all you need to click on it, and from here we need to create a workspace. Azure Machine Learning Workspace is a type of asset that will combine many different services, but it will enable users to build models and to do all the data science work. So let's quickly look how to do it. We click on create button, we click on new service. Here we need to specify what subscription and which resource group you need. If you don't have a resource group, you can actually create it from here. We need to give it a name, something that is not used. Choose the region, which the closest for me will be Australia, and then along with the machine learning workspace, other four resources will be created. The storage account will create to hold all the notebooks, all the job information, log analytics, and data set that you will provide. So everything will be stored in storage account. Keyword is for, and if you don't remember, you can click on information button and see what it helps, what it's doing. So four resources, I won't go one by one, but as you continue working with the workspace, more and more resources will be automatically created to make sure that the workspace can do it completed task. Sorry for that. We can go into networking encryption and customize it. We won't do this at this stage. All you need to create a workspace here. If you click review and create, it will take 4 to 5 minutes, and workspace will be provisioned along with other services. So we won't do this. What we will do though, we will jump into the workspace that I created. And that's what will be after you create a workspace. You, from here, to go into the actual machine learning work, you need to launch the studio. And that's where the AML studio will be launched with all the data science capabilities for you. Just quickly jump back to the admin work. So I want to show you that along with when we go into the resource group, you see all these resources being allocated and created together with workspace, or when I was doing the actual jobs in workspace. So at the very beginning, we have the workspace itself. We had a keyword, log analytics, and storage account, and all other resources being just created along the journey, such as, for example, endpoint. Jumping into the machine AML studio. So first of all, you can see that we are in the workspace we created. Everything related to authentication and to storage that attached to this workspace is already encapsulated in here, so we don't need to worry about this. You can jump into all workspaces and see no other workspaces available, but it's nice to go here and work on there. On the left sidebar, you can see the menu, so the actual way to build models for authoring. Then you have all the assets required for the model building, such as datasets. Jobs is basically any work you provision for the AML studio to do. It will create a job and you can monitor and you can see what's going on and see more details. Components served as a reusable pieces of code or reusable pieces of data science projects. So this is where you can store something like a very typical data cleaning process, or splitting between validation, test, and training data sets and so on. Pipelines is basically referred to designer. That's where you can manually build a workflow with the steps that will create data model. And we'll probably dive deep and look at this at some stage. Environments will store, let's jump in, we'll store all the environments available with the libraries installed and the version of Python and a version of operating system and so on. Models, that's where you register models and where you can see all the models available for browsing, for playing around, for deploying, stuff like that. And endpoint, that's where when you're happy with the model you created and you're ready for it to go into the wild, you create the endpoint, and that's where API can hit it, or you can use it for the predictive purposes. And here in the manage compute is probably the most important part. That's where nothing can happen without compute, where you have to create a actual, you create a virtual machine or EC2, like it said in AWS, to actually do the job. All right. It's good at compute. Let's talk about compute. So there are 4 different types of compute that we can use for AML Studio. So it's a compute instance, basically a virtual machine with compute clusters. That's where they have many machines that can scale. So when you create a cluster, and if you click on new, you can see that you can specify minimum and maximum number of nodes in addition to what type of cluster you use. We won't do this, don't need for these purposes, so feel free to play around when you have time. And we have Kubernetes clusters. So both Kubernetes clusters and compute clusters are good for production jobs. So when you have work that has to be scaled very quickly and descaled back when there is no much demand on the model. Attached compute, that's where you connect something like Databricks or HD Insight to the work. So we are happy with the compute instance I'm created. It's running right now. It's just basically one machine that will be assigned to do all the tasks. So next step is to actually, we have a machine, now we need data set, we need data to work with. And that's where Azure Machine Learning Studio is, I'd say, quite complicated. You have to know the jargon and you have to understand what every step in the process. So first and foremost, no data is stored in the workspace. That's all the pointers, all the references to the storage accounts. Storage accounts are created together with workspace. So it's just pointing there. In Azure Machine Learning Studio, you have a data store. That's data store basically a referencing to the environment and referencing to the storage service outside of AML Studio. So it's referencing somewhere into Azure, into the cloud, or it can reference the local computer, and it tells what the environment requires for this. So by default, there were 4 data stores created when you create a workspace. The blob training data, that's the one that I created along the way when I was building the model, and we'll talk about it in a second. So that's the data stores. It's pointing to the storage account or storage place. Data asset is a point to the file. That's something that points directly to data and able to read it. So it can point to local file. It can point to storage account. It can point to your publicly available URL. I'll click on Create Data Asset because I want to show you 3 different types that can be used for 3 different types of data assets. So first one is a file data asset. So that basically when you have a reference towards a file and it's URA file jargon name here in Azure. Another type of data asset is a URA folder. So when you have, for example, a folder of CSV files or Parquet files and you just want to recursively use the one of the program language to read it and combine it. So that's why you can point to the folder. And very interesting ML table type. And that's one that I used for this project. First of all, it was my curiosity, and second, I wanted to play around with automated ML, and automated ML using ML table as the only possible input for the work. So what is ML table? To show you what ML table is, we'll jump to notebooks section, and we'll look into this folder. So this folder includes 2 files. First one is a CSV file that we know that has all the data about the features we need to model and output, and the second one is a ML table file. So it's a YAML file that basically have a path towards the CSV file or any other file, and then it tells how to read the file. There are more options here. You can do the subset of the CSV file, you can play with the headers and so on, but in essence, you need to have an ML table file, and it's important to have the same name, ML table without any extensions, and the actual file with data inside the folder, and point towards this folder and tell Azure Machine Learning that is the ML table dataset. If you're going back to here, so that's the available dataset telco churn. If you click here, you see that it is a ML table type, and you have more information where it stores, what's the URI, and so on. Basically, right now, we do have a dataset ready for us to create a working model. So let's jump into automated ML and see what is going on. Before we jump, though, I want to refer back to notebooks. So when I created dataset, one of the my interest was how to use Python SDK. So I probably should mention before, you can interact with Azure Machine Learning Studio using the user interface, and that's what you've been seeing me doing most of the time. You can use CLI, so Azure CLI, clicking here, and then the CLI act as a terminal. So you connect it to subscription. It will create storage automatically to it should create storage automatically to save all the work file. Doesn't work now, but anyway, I didn't use CLI much at this project. And the last one is to actually use Python SDK. So when I was creating ML table, instead of going through the steps in UI, I decided to use Python. So just a very quick notebook, and I wanted just to go through and see how it all works. So we do install the Azure AI ML library that has all the methods and classes inside. This piece of code connect to the workspace that we've created before, and it's creating a client, the MLC client object that we can use for doing all the work with workspace. Just for the check, we're running the list of all the available data stores, and you can see that it has been done before any modeling completed. So we have only 4 data stores available, the one that created by default. That's where piece of code that we created the actual ML table. So it used Azure Blob data store function. Yeah, it's a data store. It's creating a data store, so it's pointing towards the account that we use in storage account. Yeah, we're using the key for the storage account to actually be able to create this data store, and no reason to be to think about security, because by the time you see this, all the services has been destroyed by me. after successfully creating a data store, we do create a first of all, before we create a data set, we actually check that it's done, and you see there's an extra data store created in AML, which is Azure Machine Learning Service. After we create a data store, we need to create a data set. And for data set, it's going to be ML table. So we are pointing towards the file. We create an ML table type, name it telco churn, and here we go, everything created. So just to have my hands dirty, I did creation using the script. Everything can be done quite easily in UI, as you've seen before. So just click on this button and do all these steps here. All right, so we do have data set. Data is ready. So what's our next step? Next step will be to actually create a machine learning job. So I opted to use automated ML because it's, first of all, it's exciting. Second, I think it's a fantastic feature that saves lots of time, save coding time, save experimentation time by just automating this. You see, there is one job that has been done, that the one that I'm presenting now, but nothing stopping me to do another one. The job completed, took 30 minutes. It uses compute target, compute resource that we created before. If we jump inside the job, you can see all the information about it here. So we can see why it was completed. So basically, there was no improvement over 20 extra iterations. So based on the few settings that I customized for the job, for the machine learning job, it was designed to stop if there is no short-term improvement in metric. All the information that we need. The most interesting part, probably the best model summary. We'll get into this in a second. Yeah, let's jump into models. So this job created roughly around 50 models. You can see 5 pages by 10 models per page. The best model will be always on top, so it's a sorted list. I did choose accuracy metric as my target metric. There are dozens of metrics to choose from, and yeah, let's first and foremost look at how the algorithm name created. So we'll see in a second, but automated ML jobs do the scaling and normalization together with model building. So in the name, you can see the type of feature pre-processing done and the model used. The best model is ensemble model, the one that has many models together. I want to jump into view explanation quickly. I think it's a fantastic feature that allows to browse through the model and see what the output is, and it's doing it in a visual, nice visual way. So it straight away pushing us towards the feature importance plot. We see that the contract feature is the most valuable, the most important feature for prediction. We can explore the model performance. We can look at the data. We can see individual data performance and play around here. It's really powerful. I think it helps that you can do this without coding by just click on the feature. If we jump into the best model itself, we have a few nice options here. But first of all, it's a view ensemble details. So for the model, you can see actually what the model parameters are. In ensemble model, it's very interesting to see the combination of the all model used and the weight of the model. For example, the logistic regression with standard scalar wrapper occupied 40% of the importance. Next one will be 10%, and so on. Closing this down, looking at other metrics. So even though I used accuracy as my target metric, all the metrics calculated and saved for us, if we want to browse them. Yeah, and that's the best model. If at this stage, I'm not talking about data science process, we're not talking about overfitting or something, or building deep learning models. We just looking at the best model available here, and let's say we're happy with it. Let's put in the wild, let's deploy it, let's make other people use it. So there's another wonderful button, which is deploy button. It does deploy 3 different types of, it makes 3 different types of deployment. I did end up doing the real-time endpoint, which provide response straight away. You can use web service or batch endpoint. The deployment itself taking around 20 minutes, so I'm not going to do this again, but I'll tell you a few things. So as soon as you hit the deploy button, first and foremost, this model will be registered. The model will go into model list. It will have all the features like versions, artifact, endpoint, job, so you can actually see what's going on in this model. You can provide access to others to use this model, to see this model, to experiment further. And the endpoints will be deployed here, where, as you see, so different types of deployment. So we do have one endpoint created. If we click on it, we'll go into the endpoint details. You will see the REST endpoint URL, Swagger, which I won't type again. It's probably a different topic for different exercise. I do like the test feature. Before I go though, just maybe to mention that there could be multiple deployment for the one endpoint. But again, it's probably out of scope for this exercise. In a test, right here, we can actually run a test out of this window. We supply the data. Right here, the 2 possible customers. We want to see whether they will churn or not. Hit the test, and we'll see that the customer with the first list of settings probably will churn, and the second customer probably will stay with us. That's it in a nutshell about what I've done. There are more features here to use and to play around, such as Designer, for example, as I mentioned before. Let's quickly look how it looks like with the example that Azure provided. So actually, that's not the one. Let's go here. So if you go into Designer, that's a visual flowchart-like process, which you can adjust, which you can play around. You can build yourself the process using predetermined dataset and predetermined components, and these pipelines can be registered here. That's for people who don't code, don't want to use Python. In notebooks, you have an access to Git. You can connect this to your VCS code and just write everything in code locally and use a normal DevOps process. That's it for today. Thank you so much for watching. I hope you enjoyed it. I hope you learned something new. I definitely like it, and I'm going to be using this in my future work. Thank you. Bye.